night, as there were in one of the most famous cases, the so-called Phoenix Lights of March 13th, 1997. With the case still unsolved, engineers take on the challenge of determining the actual size of the craft purportedly sighted.
It appears as though we're going to have about 3 scan positions. That's probably going to take us about 4 to 5 hours.
Engineers begin a laser scan at the home of eyewitness Tim Lee, hoping to determine the size and other important data of the craft he saw. They get more details from Lee on the exact flight path.
Came right over a house like this, and then went right through that gap. That pole, just maybe about 20 feet in, the tip of the wing went right by on the same level as that pole. And there's a little hill in the middle there. The middle of the craft was probably close to that, and it almost hit it.
The engineers begin work. Ryan sets up his laser scanner at the first position, in front of Tim Lee's house.
So this yellow box contains the laser. What it does is it shoots a laser beam out about 2,000 shots a second. This lower section here is the pan tilt base. What it does is it automatically rotates the scanner. You get a full panoramic image.
The team will use that image to create a 360-degree model of the landscape, stretching from Tim Lee's house to the mountain pass, so they can determine the distance between the peaks and estimate the size of the craft Lee says passed between them.
We'll set targets in our scenes.
Okay.
And then we will tie those to geographic coordinates, latitude, longitude.
To do that is a 2-part process that involves both scanning and GPS technology. The first step is to scan from 3 positions: Tim Lee's front yard and the near and far sides of the mountain pass. While Ryan scans near Tim's house, the rest of the team is at a second position, scanning the mountain.
You stitch these 2 data sets together from these 2 different captures, and you'll have one actual geography map of the V through which the craft was reported to have flown.
The results are dramatic. The first images of their kind, based on an actual UFO sighting. The massive UFO comes to life, just as Tim Lee remembers it, flying through the gap in the mountains. The scan reveals that the peaks Lee saw the craft pass through are exactly 1,542 feet apart. Larger than 5 football fields, Lee reported that the tips of the craft's wings almost touched the hills. So, engineers estimate that the craft must have been close to 1,500 feet wide. A silent, flying monster, nearly 1/3 of a mile across. Back at Arizona State University, physicists Pavlos Michaelides and Darrell Smith begin to analyze the 3D scan data from the reported UFO.
Time gives it enough acceleration to explain these.
Using the scan, as well as eyewitness testimony, they'll hypothesize what it would take to build and propel such a massive craft, and maybe determine what exactly Phoenix residents saw that night. The first thing they notice is that the size of the reported craft is unimaginable.
We have a low-flying aircraft of some sort that is 1,500 feet across, and it is massive by its very nature.
Let's assume that it's made out of material that we know or that we have flown before in space.
The scientists establish a baseline. For the moment, they'll assume that it's made of known materials, like aluminum, titanium, or composite. Based on those materials and the estimated size, they roughly calculate the craft's weight. They use the space shuttle as a reference. The shuttle measures about 184 feet from tip to tail and weighs 4.5 million pounds at liftoff. This craft would be about 8 times larger. That could put it at about 36 million pounds. The question is obvious. How could something that massive lift off and fly? Based on existing technologies, the options are few.
In order to suspend it and cause it to hover for any extended period of time, there needs to be some kind of propellant. There needs to be some kind of rocket that is holding it up and keeping it suspended over the ground for long periods of time.
To actually put into perspective those kinds of dimensions, those kinds of sizes and weights, we're basically talking about only rocket systems that can provide that kind of thrust.
Thrust is an aerodynamic force that propels a craft. It takes thrust to counter the Earth's gravity, to get a vehicle airborne, and then to overcome drag once it's flying. And a craft must have greater thrust than weight to take flight. But how much thrust would it take for this huge UFO to take off and fly? Engineer Alan Middlestad uses the weight estimate of 36 million pounds to tackle the problem. Having worked on the Apollo space program, he's well versed in the most powerful rocket engine ever flown, the F-1. With 1.5 million pounds of thrust each, it took 5 of these engines to propel the 6.5 million pound Saturn V moon rocket off the launch pad. He clearly remembers the spectacle of a launch.
When you're down at the Cape and you witness a Saturn V launch, you're looking at 7.5 million pounds of thrust. And just that 7.5 million pounds of thrust is sensational. The Earth shakes, it's like an earthquake.
But a spacecraft the size Tim Lee reported would require the equivalent thrust of about 6 Saturn V rockets, powered by about 30 F-1 rocket engines.
If this would have passed overhead with conventional propulsion that we're talking about now, with just the fire and just the overall thrust, it would almost be like 5 tornadoes coming through the neighborhood. I mean, it was just phenomenally powerful.
In short, it would obliterate everything in its wake. Yet nobody reported flames, smoke, or raging winds. And there's another reason rockets are problematic.
The real limiting factor in all of this is this makes a tremendous amount of noise, and yet they say it's silent. And if it's silent, it just can't be done with rocket engines.
Combustion is noisy, definitely, definitely.
So the scientists rule out the possibility of a rocket-powered propulsion system.
So conventional chemical rocket cannot really be the propulsion source.
But engineer Jack Rutherford has another idea. He considers cutting-edge rotorcraft technology, like that made by MD helicopters.
One of the things people say that they saw during the Phoenix Lights was a large craft flying very slowly or hovering. And the best way to look at the feasibility of a craft doing that is to take a look at the technology available on a helicopter.
Spinning rotors give helicopters the lift necessary to hover in midair. And unlike airplanes, rotorcraft don't need speed to create lift. They can safely fly lower to the ground and slower than airplanes. UFO witnesses Lee and Fortson said the craft they saw flew low and slow, but they didn't report seeing any external rotor assemblies. Engineer Rutherford, however, suggests a design that might account for that.
One would suspect that the lift system is self-contained within that vehicle.
In other words, maybe the rotors were embedded inside the UFO, something virtually unknown in current rotor technology. Witnesses reported seeing glowing circles beneath the wings of the craft. What if there were rotors hidden in those circles? One problem: the rotors would then need to be interconnected, using cumbersome and heavy drive shafts and transmissions. And there's another significant side effect.
If the craft had had rotor systems embedded in it, observers would have felt huge downwash, which is winds greater than any kind of a hurricane that we would experience from a weather situation. They would also be accompanied a large amount of noise. None of these were reported by any of the observers.
So given the limitations of today's technology, scientists are forced to rule out rocket power and rotor systems. But that leaves them with no explanation for how such a craft could fly. That is, if it used earthly technologies.
The biggest challenge, the bottom line, basically is where does the energy come from? Well, I know of no technologies, mature technologies today that can do such thing.
So it seems a craft as described by the witnesses would be